In this video, we're going to talk about the area of a non-right triangle. What you saw on the worksheet from Wednesday is how you could find the area of a non-right triangle using your geometry formula, area equals 1/2 base times height. What I want to do is show you how we can transform that to make our life a little bit easier for non-right triangles. So here's triangle ABC. It's not a right triangle. But in this triangle, I could find the height by dropping down a perpendicular and creating a right angle. And since angle B is up at top, I know that the base is side B down here at the bottom. So there's my 1/2 base times height. Using a little right triangle trig, I know that if angle C is over here, then side C happens to represent the hypotenuse, also known as side AB. So if I use my right triangle trig information for angle A, I know the sine of angle A is opposite over hypotenuse. Let's cross multiply. And that gives us a hypotenuse equivalent to C sine of A. I'm going to take this value for C sine of A, substitute it into my geometry formula for area of a triangle, and I'm going to come up with a new area which says 1/2 side B side C times the sine of angle A. And this is the area of a non-right triangle. This is the formula that we're going to explore today. You can see that the way that I came up with the formula from my picture is very similar to the formula that's written over here at the top of the page. The difference is it's K equals. K because we don't want to mess with a capital A for area and also a capital A for an angle in our picture. So they developed it by saying K equals. You can use any two sides of the triangle and what we will call the included angle. So if we had that in the formula we created, you can see that if we have side B and side C, and then the included angle A is in between, almost making a side angle side situation. Okay, so that's what we're looking for here. We're looking to have this angle be known as the included angle and create that side angle side situation. If that situation presents itself in your picture, you can go ahead and use the trig formula for area of a triangle versus a geometry formula. Let me show you how it works. In question number 1, we want the area of the given triangle. There's no A, B's, and C's in this picture, so you can label them if you would like. I'm going to go ahead and say here's angle A, so 7 is side A. Here's my angle B I like, so 12.6 is side B. And angle C happens to be 33. Can you see that that 33 degrees is included between the two sides? That allows me to say that my area formula is 1/2 side A times sine B times the sine of angle C. It becomes a quick substitution problem, and then we just go to our calculator to get the actual value, rounding to the nearest tenth. I'm sticking with the K from the formula now to represent the area of our non-right triangle. So on my calculator, I'm going to do 1/2, so 0.5, times side A times side B times the sine of angle C. That gives me to the nearest tenth 24.0. And that is the area of my triangle. Look at how much easier that was than all the work you had to do for question 2 on Wednesday's assignment. So today we're going to practice this formula, and we're going to practice in a number of different scenarios where maybe we have a little more work to do before we can get to the area. The key is to make sure the angle you have is included between the two sides. So in question number 2, you'll see that I don't have that situation, right? Between side 3, sorry about that, and side 5, angle B is really considered the included angle. I don't know anything about this angle yet. So I got to do a little bit of work to help me either find that angle B or something else, like a side B, so that 55 would be my included. So let's see what we have here. We have some pairs of information. We have side C across from angle C. And then we have here angle A and side A. So it looks like as we have some pairs, I can start this question with law of sines. We want to use what we know. So we know pairs of information give us law of sines. Cross multiply. Divide by 5. Because we are looking for an angle, we're going to do inverse sine of 3 sine of 55 over 5. That's going to give us a value for angle C. So let's go and find out what that is. So we have inverse sine 3 sine of 55 over 5. Let's make sure I remembered that correctly. That gives us approximately 29.4 degrees. If you're wondering whether we can find that in the second quadrant, if I were to deduct 29.4 from 180, I'm at about 150 degrees, give or take. That doesn't work with the 55, so I know that that extra value doesn't work, so we can only make one triangle. And now that I have angle C, let's find angle B. So I'm going to do 55 plus 29.4. That looks like it gives me 84.4. Let's subtract that from 180. Oops, subtracted wrong. Subtract correctly. Use your calculator if you don't like decimals. This tells me that I have now found angle B, which is my included angle. Now that I have my included angle, I can find my area. So in this picture, area equals 1/2. We're going to go side A of 5, side C of 3, angle B of 95.6. Type that in our calculator, and that's going to come out to be approximately 7.5. I did that on my handheld calculator just to save a little flipping of the screen for you. Okay, number 3. This time you are given the area and they're asking you to find the angle. So as soon as I see that I have area of a triangle, I'm going with my formula, 1/2 AB sine of angle C. Let's see what we know. Our area is 325. Side A is 22.5. Side B is 47. We're looking for the measure of angle C. So here we got to do a little work on our calculator before we can find angle C. So let's do 1/2 of 22.5 times 47. That gives us 528.75. I'm going to divide that number to the other side so that I can go ahead and find inverse of our angle. So we have inverse of C equals 325 divided by 528.75. Let's type that in, see what we get for angle C. So we'll do inverse sine of 325 divided by, grab that 528. That looks like it gives us approximately 37.9 degrees. We want it to the nearest degree, so we're going to round up to 38 degrees. Good. On the next page, we have a couple more questions that we can use to find area here. Question number 4. This is a very standard application. We're going to make a triangular plot of land. We know, because everybody makes triangular plots of land these days, right? Where two sides are given in yards. So let's construct our triangular plot of land. 510, 840. The included angle, that's important because that tells us our angle here in the middle is 110 degrees. Land is $2,000 per acre. So notice here they're giving us yards. We have to convert to acres. Okay, if you don't know that conversion, I found it for you. It's right here. We want to know, first of all, how many acres of land we have so we can figure out how much it costs. So first thing we're going to do is we're going to find the area of our triangle. 1/2 510 times 840 times the sine of our included angle. That's going to give us, use my correct variable of k right there, 201,282 point, lots of decimals. But this is square yards. To convert it to acres, we're going to go ahead and divide out that 4840. So when we do that, our area is going to come out to be 41.587 acres. And then since each acre costs $2,000, to get the cost of the land, we're going to take our 41.587 acres and multiply by $2,000. That's going to give us a total cost of $83,174.45. It's money, so we can round to the hundredth in the end. You'll notice that I didn't do any rounding as I was going through that question. Number 5, a little bit more geometry in this question. The area of a regular hexagon, that's 6-sided, by the way, is inscribed in a circle of radius 8. So here's my picture, circle of radius, radius of 10. I don't know where I got the 8 from. Radius of 10. So that tells me that as I go around my picture, I have all these 10s created on the inside. Kind of looks like spokes of a wheel. I'm going to move this 10 over just a little bit so it doesn't look like an angle. Can I find an angle there? We know that a full circle is 360. We divide it into 6 congruent triangles. That tells me that this angle is 60 degrees. So if I want to find the area of my hexagon, I actually have an included angle between two sides, because if the radius is 10 here, then the radius is 10 here. So my area is 1/2 10 by 10 times the sine of 60 degrees. Even though I know the sine of 60 degrees, I could still use my calculator. But since there's no rounding in this question, I'm going to go back to some right triangle trig, good review for us. And I'm going to draw myself a 30, 60, 90 triangle. Opposite of 60 degrees is √3. So sine of 60 is √3 over 2. So half of 100 is 50 times √3 over 2. Looks like the area of our hexagon is 50 √3 over 2. Now, that's only one of them. So keep in mind, this is one hexagon. Or, I'm sorry, one triangle. Goodness, one triangle. We want to find a hexagon. How many did we have? 1, 2, 3, 4, 5, 6 of them. So let's take this value here, multiply it by 6, reduce. Looks like our area is 150 root 3. Okay. Last question. A town board wishes to plant sod on their village commons in the shape of a triangle, of course, whose sides have a measurement of 120 feet, 165 feet, and 200 feet. Doesn't matter which side gets which measurement. The sod costs 35 cents per square foot. As soon as I see that square foot, it reminds me that I need area. And in order to find area, I need an included angle. Going back to what we talked about on Tuesday, when we have three sides, the law that we want to use is law of cosines. And we know in law of cosines, we always find the largest angle first. So I'm going to call that angle x my unknown. So look up your law of cosines, and we know that a squared equals b squared plus c squared minus 2bc cosine of angle A. So in my picture, here's my A because it's the pair of information, right? It's the two pieces that are the same. That's how you start and finish your question. And then we have a B and a C. Let's fill in what we know. A is 200 squared. B is 165 squared. C is 120 squared. I'm going to use my handheld calculator to type this in because it's going to be a lot of flipping back and forth between two screens. 200 squared is 40,000. 165 squared plus 120 squared is 41,625 minus 2 times 165 times 120, 39,600 cosine of angle A, or x, depending on what you wrote in your equation. Let's subtract the 41,625 from both sides. And that gives us negative 1,625. Divide both sides by that negative 39,600. That way we get a value that we can do inverse cosine of. So that reduces to 65 over 1584. I'm going to do inverse cosine of that number. Leave that in there to get angle A. So inverse cosine results in an angle of approximately 87.648 degrees. And then that entire angle, no rounding, so put the dot, dot, dot there because you want to use all your values, is going to then give us our area. Because now we have this piece up here, which has an included angle. So that's 1/2 side times the sine of that angle we just found. You can pause this or you can type it in yourself if I'm going too fast for you. That gives us an area of 9891 points. Lots of decimals. Let's go back and read the question. So what did I find? This is the square foot area of our triangular plot of land here. It's 35 cents per square foot. So that means I'm going to take this value, and in order to get the cost of our land, I'm going to multiply 35 cents by our area. Round to the nearest hundredth because it's money. And that tells me that this pound piece of land, $3,462.08. For homework tonight, you are going to practice your area of a non-right triangle, pages 21 and 22. This is actually due on Monday because there is no school tomorrow for you. Have a great day.